Hello, I'm JW. This time we're going to have a look at the phase converter in a bit more detail. I'll say last time we just basically wired it up and made sure that it did actually work. As I say, it had been transported and whatever else, so just really confirmation of what we already knew. And as we saw, the voltages were reasonably okay. They were sort of a bit unbalanced, but generally within the right sort of area. Now this time we're going to have a look inside the basically the control box. But first of all, we'll just have a quick look at the three components we've got on the floor here. And let's say we'll take the control box apart and see what's going on inside. So here's the components here. That's the electric motor there, just a normal three-phase motor. This is wired up in a Y configuration, or also known as a star configuration. And that's so we can have three phases and also the neutral point in the middle. This box here is a transformer, and the deal with that is that 230 volts goes in, and then around 400 volts comes out. So basically get a high voltage from that, but we'll confirm those voltages and things later on. Basically it's just in and out there as I've written on it. Motor just has say three phases, neutral and the earth connection there, and the wiring I've actually cut off and thrown over there. That's basically what it came with, just between the various parts, and it's some horrible old Copex style stuff with the plastic covering metal underneath, and then some kind of fibrous filler inside, and then of course the wiring. So it's pretty grubby and horrible, and the ends are all busted, so going to be getting rid of all of that. And we can see over there that basic bit of twin and earth, or twin and skin if you want to call it that, is where the power basically went in. Now I don't know how old this thing is, but that bit of wire there is actually branded Johnson & Phillips, so that's a pretty old and no longer existing manufacturer. This is the other cabinet here, and this I've just chopped off the wires on the outside, so essentially that's where the power goes in from that transformer, that's where the motor connected, and that's where the output was. So I just cut them off because I'm going to be replacing all this wiring anyhow, so it doesn't actually matter. And then on the front of it there's just those couple of meters there for the current and the voltage, and that was just an on and off switch which basically turned the motor on and off to switch the output on and off. So that's pretty much what we have there. So let's get the lid off this and see what's inside. I've also already taken bits of this apart, so let's get on with it. Right, here's what's inside. So this is the back of the front cover. So this is the switch there, just on and off, little neon indicator, and we've got the voltage and current meters over here. So not too bad, but I'm going to be replacing that anyway. And then in the bottom of the case, here's just a terminal strip. So essentially it's just the wires coming in from those three connections there, input, motor and the output, and it's just a load of connections there to link them through to various things within the cabinet. And of course some of these wires go over to the front switch there, others go inside, but essentially what we've got here is just the three phases and the neutral, and the three phases of the neutral again, and then this is the incoming, so it's going to be the two connections here, presumably a centre tap or something, but we'll look into that later, although that may or may not be the case. But earth logo over the side here again goes into there, and that presumably goes through into the back, and another one over this side here again, just probably linking through down into the metal case. Now at the top here we've got some capacitors on the left here. It's 4 of those, and there's also 4 over there of the same value. And then we have another 6 in the middle here of a different type, and for some reason 4 of these are these blue covered things, and the 2 at the back are black. So some may have been replaced at some point, or maybe they were just like that originally, but in any case not the same type. And on the top here we've also got some resistors which are there to discharge the capacitor after it's been disconnected from the supply. Otherwise it could hold a significant charge for a long time. These are almost certainly the wrong kind. These are little quarter-watt jobs, and there's 2 twisted together in parallel, which again not really the best choice. They should be better off with ceramic resistors of a fixed value, but that's what we have over there. And basically there's 2 of some of these capacitors will be used to start the motor, as you can't start a 3-phase motor on a single phase without some additional phase shifting thing there. And then these are presumably the ones which are used when it's running to generate the 3rd phase. So let's see what we've got in the bottom here. This is a contactor, which essentially is just a switch. So it's got 4 connections there. In the off position nothing's connected, and when it's on this pulls down, and then those are connected, those are connected, those and those. So it's just straight through wiring there. So with a coil connection on the bottom, so when power's applied, that basically into an electromagnet, pulls that down and connects the things through. This is a fairly old type, it's all got exposed contacts or whatever. The newer ones generally are more enclosed like that, and do not do that when there's power applied, because it will spark across here, and it's obviously fairly dangerous with 400 volts right there. Of course, this is all disconnected. This here is another relay, which is probably going to be used to switch in and out the starting function of it. So when it starts, the start capacitors are in circuit, and then once it's at speed, it will switch out the thing and disconnect those. So it's just on the run capacitors. So that's basically what we have inside. So the concept is that your single phase comes in to the transformer, which is on the floor, comes in at the bottom here, 400 volts or so. Initially, these capacitors are connected in with the three-phase motor, and that creates a phase shift so that then it can actually get rotating. Once it is rotating up to speed, then the relay will disconnect the start capacitor there, and then the run capacitors and the motor then just run continuously, basically with the three-phase coming out. So the motor is obviously acting as sort of a motor and a generator pretty much at the same time, so power's going into it, and because it's rotating, that third phase then comes from the fact that it's obviously a rotating thing and acting as a generator. And these here just say where the phase could go out, obviously to our output and to the motor as well. Now, as you can see, I've removed a fair amount of stuff from these, so most of the wiring is gone, and I've also taken out the capacitors from there. Those are actually just sitting out on the front here. These are the 2 meters from the front, the voltage and the current. This one has a heavy crack at the middle. This one didn't appear to actually work, it may have just got stuck or something, but in any case, I'm not going to be reusing them, because first of all, this is only 1 voltage meter, so it would be useful to have one on all 3 of the phases. And the current meter, so it's actually got a label on the back, which you can probably see that, but it says something about pointer high, and something like focus on swapped pointer or something, so it may well have been busted anyway, and someone just made a note there to cover that up. This is the switch, just a 2-position on and off, so no particular surprise with that. The contacts on the back are not in particularly good condition. This was actually arcing when we did that test previously, and you can see on some of these that certainly this one here, there's a significant amount of burning on that where it's been overheating presumably for quite some time. So again, not hugely useful there, although there looks to be a lot of wires on here. It's not particularly complex, it's just literally a basically 3-gang switch, so 6 terminals. When it's in the off position, nothing is connected, and when it's in the on position, pairs of these are connected together. So basically it's these 2, those 2, and those 2 there. So it's basically just the 3 phases in and the 3 phases out. These thin ones went over to the voltmeter, hence there's additional wires there, so it's just monitoring the voltage on just one of the pairs, and that is pretty much it. So claims to be rated to 16 amps, 500 volts, which should be okay, but I think the problem here is it's just been worn out because it's obviously fairly old. The mechanism is quite sloppy, and as you see there, say some fair amount of overheating has occurred on the back, a certain amount of corrosion on terminals as well. So here's a look at the capacitors. They're all the same rating. So as you see, that says 10 MF on that second line. MF actually means microfarads, not megafarads as it might imply, and that was basically because they didn't print the little micro symbol on at the time. So 10 microfarads, 370 volts AC, which seems a bit on the low side considering this is a 400 volt output, and bizarrely 60 Hertz, which doesn't make a lot of sense because in the UK frequency is 50, and doesn't have any PCBs in, which are those toxic chemicals which cause cancer and whatever, so quite nice to see that on there. That 2085 is presumably the date, so week 20 of 1985. So these are pretty old, and we're not going to be keeping these, not necessarily because they're completely faulty, but because they're leaking, which is why they're sitting on this piece of paper, so fairly unpleasant. Now I'll just do a quick check on the capacitance. We use this multimeter here, and capacitance dimension around the bottom there. the yellow button to get that. Now I'll say these are supposed to be 10 microfarads each, so let's just see what we have. So let's go straight on the terminals here. Okay, that's showing us 11, so about 10% high. 10.6. Just shy of 11 again. Yeah, around the 11 mark. 10.5. 10.9. 10.7. And finally 11 exactly, 10.9. So in terms of the capacitance, these are reading in the correct value range. They're sort of within 10%, which is perfectly fine for most capacitors. So at first face value, these are fine, but I say the problem is these are oil-filled capacitors, and they're also from 1985, and so unfortunately they are actually leaking. So a nice deposit there, sort of seepage out of it. Now, of course, prying about the case may have caused a bit of damage to cause that one to leak a bit, but if you look at the top of these, they're all covered in oily residues anyhow, so also been leaking for years. So all of these appear to have the correct capacitance value, or at least within 10% or so. But I thought we'll just try this thing here as well. This also displays the equivalent series resistance, which ideally should be as low as possible. So let's just turn that on, and it does the capacitance as well, obviously. So let's connect onto that one. Go with 9.80 microfarads and 0.04 ohms ESR, which seems perfectly fine. Let's try that one. And pretty much the same result. Yeah, 0.04. Yeah, 0.04. So it's fairly consistent doings. Yeah, pretty much the same. .05, so again nothing surprising with that. Yep, 0.04, and finally 0.04. So again, they all seem to be within the sort of working parameters of it. So 10 microfarads and say ESR in the milliohm sort of range. So that's perfectly fine. But say I'm going to be replacing these because unfortunately they are leaking, as you can see on the top there, and certainly one of them is also leaking from the bottom as well, which is certainly not what we actually want. And plus they're from 1985, so even if they are in perfect condition, they're pretty ancient and certainly not the best in the thing. So there we go. Contains combustible fluid, yeah, so there's another big negative for it. So they can be going straight into the scrappage bin. Now just have a look at this here. This is a 4-pole contactor, so 1, 2, 3, 4. But it's actually wired up just as a single switch because 2 wires coming in the bottom here, and you see those are linked across to here, and these 2 in the middle. But then also these 2 wires actually go down to the same terminal here. So essentially all 4 of these are all linked together, and therefore when this switches on, all 4 of those are going to link together as well. So these were the wires that just go over to these 6 capacitors. There they are at the top, and what's coming out was basically a single wire. So these are all just wired up basically as a single pole switch here. Not entirely sure why they put the massive number of different contacts there, probably to get a higher current rating or something maybe, but it seems a bit odd they would have just used that. But anyway, that's what we've got there. And then say just these 6 electrolytic capacitors here. So there's 4 of these Mallory things here, made in the USA. Well, there's something you don't see anymore. 190 microfarad, again, that MFD thing there, 400 volts. There's codes and things on there. So those 2 are the same. And then here we've got another one of those Mallory 190 jobs. But on the back here we've got these much physically smaller ones, which are Chemits. 220 microfarad, and notice it's got the little microfarad symbol, so these are considerably newer, also made in the EU, so obviously there. So these are 220s and also 400 volts. And then here, again, the Mallory one again, and another Kemet. So it appears that these two have been replaced. They would have presumably been all the Mallory ones originally. Someone's put in these blocks here of just aluminium, it feels like. Yeah, just to space them off of the bottom. These are probably just offcuts of some machine or something like that. So 6 of those, but 4 appear to be original, 2 have been replaced. A rather strange choice, because if some of these had failed, which they presumably had, why wouldn't you just replace all of them instead of just 2 of them? So, a bit of an odd choice there. And this is certainly an odd choice for this old arrow contactor, so it's just being used literally as a single pole switch, but all 4 basically wired in to use. Now these have also got the little bleed resistors on here. These are used to start the motor, and then they should be switched out of the circuit. And of course, charging a capacitor and then switching it out would result in the charge remaining on these. So it's got these resistors here to just remove any charge which is left. So no doubt they work, but they're literally just the little quarter watt things, 2 of them twisted together. No insulation on the leads, all a bit crap really. So let's cut all those off, and then we'll just test these capacitors as well. Now just a quick look at these resistors. So we've got 2 in basically parallel there, so it's at 15k or so presumably 30k resistors or that sort of area. 13.6, yes, and then this one's got a busted one because it got damaged, but 30.7, and this one remaining 27, a bit all over the place. That one's 28 for the 2, or for one of them. So yes, they're sort of in the region of 15k or so. And 28 obviously individually, so yeah, presumably 30k odd resistors, although that's a strange value. They do have the remains of the colour marking on them. You can see those. Good luck, you've got better eyesight than I have. So in that sort of area, that seems a bit on the low side for bleed resistors on a capacitor, but there we go, that's what we got. Now let's just have a look at these capacitors then. So these are supposed to be 190 microfarads, as in the M for micro, not mega. Imagine if that was 190 megafarads, how much energy you could store in there. You could power the world with that. Now let's see what we got then. So 185, so again that's not too far off the mark. So 188 and 185, then over here yes, well that's not looking very promising, is it? 850, no 560, so something definitely wrong with that one. Let's put that over there. So yeah, it's definitely some kind of problem with that. And then these are the newer ones, these Kemet ones, 220 microfarad they should be. Let's see what they've got on them. 193, that's certainly a bit on the low side. And this one here, 201, so again that seems a bit low as well. So certainly not the best. And then there's this busted thing here, which 870, no, that completely, it's just going all over the place, isn't it? So something's definitely gone wrong with that one. Try this Duff capacitor with this other tester here. Okay, that measures 217, which is rather on the high side considering it's only supposed to be 190. 0.14 ESR, so not entirely sure what the deal going on with that one. Let's just do one of the black ones as well. Or maybe not. There we go. 194, so yes, these seem a bit on the low side despite them being new. This seems to be a bit wrong on that other meter, but better on this one. And let's just check one of the other ones on that. Yeah, 177, so again, that seems a bit low on that one, to be 190. So now, as you can see, there's not a whole lot left. There's just these terminal strips here, which I've cut most of the wires off as I made a note of where they connected. This little relay, we'll have a look at in a minute. And then there's the contactor there, which we saw before. So, see it from the top there is a bit clearer. So essentially, it's just 4 contacts. So 1, 2, 3, 4. When that's pressed down, the metal bits just link each pair together. See the details on the side here. So it's an arrow made in England, and 20 amps, 250 volts or less. And there's other ratings there. It's an AC1 rating. Terminals there labelled in the usual fashion. So 44, 34, 24 and 14. And on the other side, 13, 23, 33 and 43. So this just goes straight through. And the coil contacts there, A1 and A2. You can see it's a coil of 220 to 250 volts and 50 hertz, so no surprise with that. Now this is the relay here, and the coil connections are this grey and purple, rather shoddily soldered on there. Look at that, just blobbed on with a lump of manky old solder, so a bit of a bust there. And then the only terminals that we used were the 3 on this side here. So essentially we've got a normally open and a normally closed contact and a common. Common is this one, and then the other 2 there. Now the lid of this is just loose and falls off, so you can see what's inside. Coil contacts here, they just go onto this coil of wire here. So when it's energised, it becomes a magnet and it pulls this down. And you can just about see in there, contacts move across. So normally this one and the top one are kind of connected together, and then when it's powered up, that just moves across, so then it's this one and this one. So the bottom one and that one, or when it's not on, the bottom one and the outer one. I've sort of got another set of contacts over there, but they weren't connected, so not currently in use, and so the lid should not just fall off like that, because obviously it's been broke. But the most surprising thing about this relay is the rating. Coil 120 volts AC, so that fits in with the Made in America thing that we saw before, as you wouldn't normally use 120 volts AC in this country. And the contacts, again, 120 volts AC and 30 volts DC if you wanted to use that. Now the problem with this is that the contacts it was switching for that relay was actually 240, so that was being overloaded. And if you're wondering how that worked on 120 volts, well, let's have a look at the diagram. So here's what we had. So the coil is here, grey and purple, and in the purple lead was this 22k ohm resistor. It's this quite large thing here, so basically we're just using that to drop the voltage, so a huge amount of power was just going to be thrown away in this. It would have got pretty hot, and that goes across to, in this case, one of the motor terminals, L2 there. The grey one, this is not a very good diagram, but grey actually connects back to the neutral from the transformer, which presumably is common with the neutral from the motor, though we haven't confirmed that yet. So the way that this supposedly works is we've got the transformer power coming in here, so one marked neutral and one marked L1. Now exactly what the voltage is between those isn't yet clear, but we'll find out when we look at the transformer. So I say the neutral went to one side of the contactor coil, grey on the little relay, which again was one side of the coil there, and also one side of a neon indicator which was in the front panel. So that's just basically a neutral connections to all of that lot. So the other side of the contactor coil goes to contact 1 on the relay, and the neon indicator, the other side of that goes to number 2. And then the third contact on the relay, which is 3, and that's actually the common connection, goes to this L1 coming in from the transformer. So in its default state, in the sort of off condition when there's no power being applied, basically the contactor is actually connected. So this power coming in from the transformer L1 will be connected over to contact 1 there, so those two will be linked. The result of that will be that the contactor coil will be energised, and that would connect those starting capacitors into the circuit. However, once the motor is started, and we've got that down the bottom here, so motor L2, that would actually power the small relay coil via this big arse resistor here, back to the grey on the neutral there, which is connected up here. Once this relay is powered, the contacts will switch over, so The contactor won't be powered anymore, so that will drop out, so there will be no connection to the starting capacitors, but it will connect the little neon indicator. So it appears that the neon indicator is using to say basically ready or it's started, and so when you first turn it on, the light's not on, the contactor coil energizes, the start capacitors are put in circuit, the motor then should start up. Once the motor's running, you should get that voltage coming back on L2 from the motor, which then powers this little relay, switches the contacts over, disconnects this contactor, disconnects the starting capacitors, and also connects onto this here so the little neon indicator lights up, presumably indicating that it's working properly. So a bit more detailed look at the phase converter there, and certainly that control box, which basically is a big box of capacitors, and a couple of relays to switch some of them in and out as and when the motor is starting or not starting. Now, so those oil-filled capacitors did test out okay, but as you can see on the top they were leaking somewhat, and one of them got a bit damaged when I pried it out the case because someone had glued it in with some kind of adhesive, so that was obviously bust, and I don't like oil-filled capacitors anyway, so they've gone in the scrap. And those other electrolytics which we're using for starting, again, they're not going to be kept either because they're pretty old. Two of them have already been replaced by somebody, so we're going to be slinging them out as well. And we've got the contactor there, but we don't actually want that either, so that's going in the scrap as well. And that little relay is the wrong voltage, so guess what? We're not keeping that either. That only leaves the actual terminal strips, which we're not going to keep either because those are the older style with the big exposed bits on them, so they're going away. We're going to get some DIN rail mounting ones and fit those on properly. And of course the wiring is already scrapped, and as for the cabinet itself, well, that's also going in the scrap because we've got a different one we're going to use which is considerably better than that. It actually has a proper sealed lid with a nice key on the front you can open and close. So in terms of what was in that, all gone in the bin and gone away, so we're going to be replacing that, so we're going to need to get some new components for this. So obviously when we get those we'll have a look at putting it back together. Now next time we're going to have a look at the motor, but until then, thanks for watching.